Good evening, Professor. This is my personal timetable. So, the last week we have prepared for the demo, and also we have some modification in the coronavirus biosensor research paper. And simultaneously, I'm also working on the RF review paper as well. So, in this week, I have planned to finish the writing part of these two papers. First is the coronavirus biosensor research paper and RF review paper. So slightly difference. I have some modification in the coronavirus research paper as well. So me and Prashant were discussed together and also add some content in the paper and also make a sample for the AFM and SEM and FTIR as well. So tomorrow we will fix the sample in one box and ready for delivering to the Cannes nanofab for the sampling. And the third task is the AO biosensor research. So simultaneously also getting updates from the Bruce that like what they are doing and what is there any uh, need any assistance from my side, then I'll actively participate with them to solve this issue and go proceed further. Um, so before to start my presentation, I want to uh, some brief discuss about the AO biosensor research article. Sir, as we have fixing the immobilization step because we have tried the drop casting, we have tried the spin coating, but at last we fixed the dip coating method. So we have to just check in a number of times like 15 minutes we have to dip into the solution and the 20 minutes and 30 minutes and 1 hour, and then what time we have to check. So that's why it takes time. But after simultaneously also we ordered the MUA, so we got the MUA solution, MUA chemicals. So for me, I'm also looking for like how we can measure, how we can make the sample solution of that MUA. So this is my this week plan. This are the basic three tasks that I'm going to follow up and updates in this week. Sir, as you know that we have decided two different type of titles, but the second one is suggested by the Dr. Ajit Kaushik sir, and we go with this. We have there is no finalized that title, but we just fix these two only. And the last week we already have demonstration with the other peoples. So we follow this step. As you know, the it's a biosensor research recipe, so it's a very common for nowadays in our group. And this is my table of content that we followed. That we have the tentative table of content. We have to follow this table of content, and then also uh, the more describably into the paper. So first we have to describe the abstract and introduction and the results and discussion, experimental section and the surface characterization of DIDC bionic electrodes, and conclusion and acknowledgement and the conflict of interest and references. So as I discussed with Prashant, that he decided to submit in two different kind of journals. Like first is advanced materials, and the second one is the AFM, advanced functional materials. There are two basic journals that we have planning to submit this paper. So first we are focusing on the content, and as you gave us the deadline, like on Wednesday submit we have to submit this paper to you for your review. So as per the as per the deadlines, so we have for more focus on this paper and to set all the contents in the basic things. And this is the abstract that we have, the finalized abstract. And this is the basic figures that we have to put into the paper. And this is the basic results that we have followed in terms of sensitivity and the selectivity as well. And also, sir, as I said earlier in this PPT, that we have prepared the sample for the SEM. So we have prepared the sample of for the antigen pictures and sent to Khan's Nanofab tomorrow. And on 4th of January, we have the characterization sampling analysis in the cons, and the same day we got the results. Then we put the sample results into the paper, and this is the FTIR. So there is no such change in the FTIR, but we are looking for the make specific bands, and to then we have to finalize. And for this one also is AFM, so we have to take the picture of antibody and antigen. So we have already prepared the samples for to send the cons nanofab for the sampling analysis. And this is the water contact angle measurement, and this is the basic video for the demonstration of this whole scenario in a one video. So the results is quite impressive, and then we have to fix this kind of images in the supplementary as well. So this is the summarization of the AAO biosensor research, but we fixed with the two different kind of materials. AAO, that is having two different kind of nanometer pore sizes, 70 and 95 nanometer pore size, and interpore distance is 125 nanometer and thickness is 300 nanometer. So the gap between the several like the gap between the two, or like two pore size, is having the 125 nanometer, and highly ordered nanopore array structure is facile fabrication. So it's just a kind of sophisticated material on the glass. And the AG nanoparticle with the protein complex is having 20 to 70 nanometer according to the 2-time SEM, and concentration is zero point 0.1 millimolar per molar milliliter. It's a 10.8 milligram per ml. And the protein is unclear concentration because there is no as such a specific concentration we got from the another lab. The synthesis process is also not controlled. Is AG nanoparticle hard to reduce size because after synthesis, because it's having the and protein content, and for the synthesis part we have to have make higher temperature reduction system, so it's impossible to uh, reduce the size in the presence of protein, because the protein, if we increase the room temperature or the specific uh, temperature, then the protein denatured, and there is no as such activity in the sample. And the size reduction, we have used water bath ultrasonic and probe ultrasonic. So the fabrication, as I already said before, the spin coating, drop casting, dip coating, and ultrasonic spray. So spin coating is not going worth, and the drop casting as well. And now we focus on the dip coating. So it cannot coat on glass and AO. It takes 1 hour and 12 hour and glass and AO. So the results showing clear LSPR absorption band, but antibody and antigen evaluation did not show LSPR shifting. So we have stuck in this at this stage because um, now we have the MUA sample, MUA solution. So tomorrow I have make the sample and discuss with Bruce like how we can measure the sample and then what solvent we have to use to make the solution. So tomorrow we will fix it, and this is our new conceptual structure. Like we have the glass and then AO pore and the nanopore area in between two pore sizes, and the OH group is having the APTS and the APTS, and then Ag nanoparticle is on the is act like a bead on with connected with the APTS. So this is our main conceptual figure, so we have to make it like this, but in the meantime we have to focus on the MUA sample as well. So it's the basic, the analyzation is the surface modification process with the piranha treatment has been already verified because both of coated glass and LSP results showed coated Ag nanoparticles as well. Hydroxyl group showed modified on glass surface with piranha and the solution, and the second LSPR peak near first one possibly returns from different intergap between the Ag nanoparticles or dimer form, and the dispersion can be used at room temperature at least 1 hour of the Ag nanoparticle onto the surface, and drop casting is a candidate method to coated Ag nanoparticle on AO instead of dip coating because Ag nanoparticle basically is just a part having the particles like the Ag particles. So if we put into the glass and making a drip coating, so is not the appropriate method we have checked through the LSPR. But if we use the drop casting is a uh, favorable method as compared to the dip coating. So the improvement is basically in this experiment is testing piranha solution on AO to modify OH, and extending coating time and research on different coating time, because we have to check the time at what time we got the coating on the surface, and using ethanol every time to rinse substrate after APTS to remove physically absorbed APTS, and applying rinsing properties agent and particles to coating to remove physically attached agent and particles. So sir, we are stuck in this immobilization process, and we are working on it. We have searched so many literatures like what they are using and what they did, how they did. So every time we discuss together, me and Bruce, like what is the basic step that we have to follow in this case. But we are trying our level best to in terms of immobilization, and hopefully in this week we will tackle the situation and to get the solution, like what immobilization step we have to take in for this better results. And of course we are grateful to have your comments as well. So in the meantime we also discuss with the pros like how we can handle this situation, and also get your comments as well after the this PPT. So thank you, sir.